Okay, we've all heard the name Isaac Newton, right? The story about the apple, gravity, it's classic stuff. But what if I told you he basically wrote the hidden source code for our physical world? In this explainer, we're going to uncover just how deep his influence really runs, connecting the past to our present in ways you probably never expected. So, let's kick things off with a little puzzle. You've got a satellite whipping through space, a massive skyscraper anchored to the ground, and the wild ups and downs of the stock market. I mean, they seem totally unrelated, don't they? But what if they all operate on the exact same set of invisible rules?
Believe it or not, the answer is the work of one man, Sir Isaac Newton. Yeah, that brilliant, super secretive, and by all accounts, kind of difficult genius from way back in the 17th century. And his work? It's the foundation for so much of what we see and do every single day. So first, let's actually trace that influence, because it's hiding in plain sight, woven into pretty much every part of our modern lives. And you know, our story doesn't begin in some bustling, state-of-the-art lab. Nope, it begins in forced isolation, a quiet period that paradoxically ended up sparking a massive scientific revolution.
Picture this. It's 1665. The Great Plague is raging, and it forces Cambridge University to shut down. So, a young student in his early 20s named Isaac Newton has to go back to his family home. And in the 18 months that followed, he wouldn't just change science. He would literally rewrite the rulebook for the entire universe.
This period of isolation became what's now called his Annus Mirabilis, which means Year of Wonders. And that's no exaggeration. It was one of the most intellectually productive times in all of human history. Just him, alone with his thoughts, laying the groundwork for 3 breakthroughs that were about to change, well, everything.
So, what did he cook up during this time? Well, first, he invented what we now call calculus, a whole new kind of math to describe a world that's always in motion. Second, he figured out the nature of light, proving that plain old white light is actually a mix of all the colors of the rainbow. And finally, gravity and motion, the incredible idea that the same force pulling an apple to the ground is what keeps the moon circling the Earth.
But here's the twist. Newton was incredibly secretive. I mean, these world-changing ideas might have just stayed locked away in his notebooks forever if it wasn't for a visit from his friend, the astronomer Edmund Halley, who basically had to convince him to publish his masterpiece.
So the story goes that Halley asked him a pretty simple question about what shape a planet's orbit would be. Newton just casually said, "Oh yeah, I calculated that years ago. It's an ellipse." That conversation lit a fire under him, sparking a 2-year marathon of writing that resulted in what is arguably the single most important scientific book ever written, the Principia.
So what's inside the Principia? You can think of it like a user manual for the cosmos. He laid out his 3 laws of motion, explained universal gravitation, and proved that planets move in those elliptical orbits. For the very first time, the same set of laws applied to a falling apple on Earth and the planets spinning through the heavens. It was a unified theory of, well, almost everything.
Okay, so how does this 17th century book actually affect our world today? Let's trace the connections directly from his laws to our everyday lives. It's pretty amazing.
All right, first, let's talk about the impact of his universal laws. They gave us this mechanistic worldview, this radical idea that the universe is predictable, that it runs like a clock. This is the absolute bedrock of all modern engineering. Every single skyscraper, every bridge, every satellite we launch is built on the calculations Newton gave us over 350 years ago.
Next up, his invention of calculus. Now, I know what you might be thinking, flashbacks to high school math, right? But it was so much more than that. It gave us the mathematical language to describe a world that's constantly changing. And today, it's absolutely essential in just about every STEM field, from modeling financial markets to rendering the mind-blowing computer graphics in the movies we watch.
And finally, his experiments with light. By showing that white light is really a spectrum of colors, he basically gave birth to the field of spectroscopy. This is what lets us analyze what distant stars are made of, just by looking at their light. And it's the foundation for modern tech like fiber optics and the powerful telescopes that let us see across the universe.
So this brings us to a really important question. If we have Albert Einstein and his theory of relativity, why is Isaac Newton still a fundamental, absolutely non-negotiable part of every single science and engineering education on the planet?
Well, the simple answer is that Einstein didn't replace Newton, he expanded on his work. Einstein's theories are for the universe at its most extreme. We're talking massive gravity, like black holes, and speeds that get close to the speed of light. For example, the GPS in your phone only works because the satellites use Einstein's equations to correct for tiny changes in time. But for pretty much everything else, Newton's laws are perfectly accurate.
For almost everything we build, design, and launch right here on Earth, Newton's physics isn't just good enough, it's the perfect tool for the job. You can really think of his laws as the operating system for our everyday reality. But, maybe Newton's single greatest gift wasn't any one discovery. Maybe it was the method he perfected, combining what you can see and measure, that's the data, with hardcore mathematical theory. He taught us how to do science, and that process is still the gold standard today. And that leaves us with one last thought. Newton proved that the universe isn't some random, unknowable mess. It has rules, and we have the power to figure them out. He solved the great puzzles of his time, which just makes you wonder, what fundamental rule, what modern apple, is just waiting to be noticed, ready to reveal the next great secret of our universe?